Good morning students. Today we will discuss about different biasing conditions. Biasing conditions in PN junction diode. So what are the different biasing conditions? One is unbiased or zero bias. Means whatever PN junction we have discussed in last class, that belongs to unbiased or zero bias. Because no external voltage is provided. When no external voltage is applied to PN junction, that we call it as unbiased or zero bias. Next, when we give external voltage across the PN junction, then there are two biasing conditions. One is forward bias and another one is reverse bias. Okay, we'll discuss about this briefly. Forward biased PN junction diode. So, when we call the circuit is forward biased. So see here, when positive terminal of the battery is connected to P-type semiconductor and negative terminal of the battery is connected to N-type semiconductor, then it is called as forward bias PN junction diode. Next, the bias applied is known as forward bias. Okay, now let's see this. Here, when forward bias is given, this is the PN junction. PN, the semiconductors combine to form PN junction. Next, what is this? This is the depletion region. In the depletion region, there are no mobile charge carriers. There are only immobile charge carriers. There are no electrons and holes. Immobile charge carriers. They are acceptor ions and donor ions. Now, for this PN junction, we are applying forward bias. Forward bias means positive terminal of the battery should be connected to P-type semiconductor and negative terminal of the battery should be connected to N-type semiconductor. So what happens? What are the majority charge carriers in P-type? Majority charge carriers are holes. Holes carry positive charge. So here terminal positive and these holes also positive. Positive, they will repel. And these holes move towards junction. They will be moving towards junction. They will be moving towards junction because positive repels. Next, here it is having negative charge, negative terminal of the battery, and here electrons are the majority charge carriers. Electrons carry negative charge. So this negative repels. So they will be moving towards the junction. These electrons also moving towards the junction. So what happens? These holes are entering into junction and these electrons are also entering into junction. So what happens is, here I can find in this region mobile charge carriers, electrons and holes. Means it is no more depletion region. So after some time the depletion region disappears. So what happens initially, the width of the depletion region decreases. After some time it disappears. Means electrons are free to move from P region to N region. Electrons are free to move from N region to P region and holes are free to move from P region to N region. So this results in flow of current. So here in forward bias, the current is measured in milliamperes. It is measured in milliamperes. So see here what we have discussed. Forward bias PN junction diode means positive terminal of the battery should be connected to P type. Negative terminal of the battery should be connected to N type. So what happens here? Majority charge carriers in P type are holes. Holes carry positive charge. This positive repels and they move towards junction. Here majority charge carriers in N type are electrons. This negative repels and they will enter into junction. So here in the junction we can find mobile charge carriers. Means this is no more depletion region. So width of the depletion region decreases and it disappears. So due to the flow of these electrons and holes, it produces current that is measured in milliamperes. So you can see here under forward biased condition, the applied positive potential repels holes in p-type region. So holes move towards junction. Similarly, applied negative potential repels electrons and they move towards junction. So width of the potential barrier reduces. Okay, and after some time it disappears. Now, if we see the VI characteristics of diode under forward bias, if I see the VI characteristics under forward bias, you can find that, see here, this is the forward current and this is the forward voltage in volts. Forward current is in milliamperes. Now, so up to threshold voltage, what is the threshold voltage? Means junction voltage. What is the junction voltage for germanium? Junction voltage for germanium is 0.3 volts and junction voltage for silicon is 0.7 volts. Means up to this voltage the forward current is 0. The current is 0 means there is no flow of charge carriers. After 0.3 volts for germanium, what happens as the voltage increases? Current also increases. For silicon it is 0.7 volts. After 0.7 volts, as the forward voltage increases, forward current also increases. So this is about the characteristics of PN junction diode under forward bias. So see here, as forward voltage is increased for Vf less than V0, means if forward voltage is less than threshold voltage, there is no current. So the current becomes 0. The current, see here, forward voltage If is almost 0. Because the potential barrier prevents the flow of electrons from N region to P region and holes from P region to N region. For Vf greater than V0, see here, if forward voltage, this forward voltage Vf is greater than V0, this is the threshold voltage. If it is greater than V0, what happens? As the potential barrier will be it disappears and electrons are free to move from N region to P region and holes are free to move from P region to N region. So current increases. So after 0.3 volts and 0.7 volts, after cutoff voltage or threshold voltage, the current increases rapidly. So this is about forward bias. If we move for reverse biased PN junction, so in reverse bias PN junction, what happens is reverse means negative terminal of the battery is connected to P type and positive terminal of the battery is connected to N type. This we call it as reverse biased PN junction. Now see here P type is connected with negative terminal of the battery and N type is connected with positive terminal of the battery. Now, what are the majority charge carriers in P-type? Holes. Holes are the majority charge carriers. Holes carry which charge? Positive charge. So, here negative terminal they are giving, this is positive charge. So, positive, negative, what happens? They attract. So, that's why these holes move towards terminals of the battery. They will be moving towards the terminals. Here also, positive terminal is connected to N-type. What are the majority charge carriers in N-type? Electrons. So what happens? These electrons flow towards the terminal. Towards the terminal. Means these electrons are moving towards the terminal. These holes also move towards the terminal. So what happens? The width of the depletion region increases. The width of the depletion region increases. Means there is no flow of current. There is no flow of current. There is no flow of current due to majority charge carriers. So there is no flow of current due to majority charge carriers. Okay, but here in p-type there are minority charge carriers. What are the minority charge carriers? Electrons. For n-type, minority charge carriers is holes, but minority charge carriers are very few in number. So what happens for minority charge carriers? This is negative, this is negative. So these minority charge carriers move towards junction. Here positive, positive. So what happens? They repel. If they repel, they move towards junction. So minority charge carriers are able to cross the junction. Means there is small current. There is small current due to minority charge carriers. Due to minority charge carriers. There is a small current due to minority charge carriers. So it is due to minority charge carriers, which is called as the reverse saturation current. This current we call it as reverse saturation current. So this reverse saturation current will be in microamperes, 10 power minus 6 amperes, microamperes. So this is about reverse bias PN junction. So see here, if we see here, under reverse biased condition, the majority charge carriers holes from P region move towards negative terminal of the battery. It is moving towards the negative terminal of the battery. And electrons from N region move towards positive terminal of the battery. They are moving away from the junction. So what happens? The width of the depletion region is going to increase. So hence width of the depletion region increases. So the electric field produced by applied reverse force is in the same direction of electric field of potential barrier. Now here, so see here depletion region is increasing. There is no flow of current due to majority charge carriers. But there is a flow of current due to minority charge carriers. For minority charge carriers, this is forward bias. See here, for minority charge carriers, negative, negative, positive, positive. It acts as forward bias. That's why they are moving towards junction. So there is a little bit of current due to minority charge carriers, which is called as reverse saturation current. Okay. Now, if we go for VI characteristics of PN junction diode under reverse bias, VI characteristics. So see here, this is reverse current, IR, in micrometers, microamperes. We will get in microamperes. This is reverse voltage in volts. So what happens is, here there is no current due to majority charge carriers, but there is small current. There is small current due to minority charge carriers. This is the small current due to minority charge carriers. So what is that current called as? It is called as reverse saturation current. That is called as reverse saturation current. Next, when the reverse bias increases, so when the electric field of the reverse bias increases, so if I give large reverse bias, so what happens is, here, see here, this is the P-type semiconductor and this is the N-type semiconductor and this is the depletion region. What are the minority charge carriers in P-type? Minority charge carriers are electrons. In N-type, minority charge carriers are holes. Okay. Now if you give reverse bias means P-type should be connected to negative and N-type should be connected to positive. So what happens when you give large reverse bias? Here if I give large reverse bias, Here, these electrons, these minority charge carriers acquire high energies. These electrons, see here, this is negative, negative. So what happens? They will be moving towards junction. These electrons will be moving towards junction. At the junction, what are present? At the junction, donor ions are present. Acceptor ions are present and donor ions are present in the junction. Okay. Now, what happens is this electron with high speed, it is entering into junction with high speed and it collides with acceptor ion or otherwise donor ion. It collides with acceptor. This electron collides with this acceptor ion or donor ion and it supplies its energy and it pulls another electron. So what I am saying, listen to me. See here now P-N region. Minority charge carriers are electrons and here minority charge carriers are holes. When I apply reverse bias means P-type is connected to negative, N-type is connected to positive. So negative negative repels and they move towards junction. Here positive positive repels and they will be moving towards junction. Okay, at the junction what are present? Acceptor ions and donor ions. So when I give large reverse bias, this electron acquires high speeds. These electrons will be acquiring high speeds. So with high speed, this electron collides with junction. In the junction, they are present acceptor ions or donor ions. They collides with this ion. It supplies its energy and it pulls another electron. Again, these electrons collides with other crystal ions. Again, these electrons collides with other crystal ions and it pulls electrons. So like this, you will be getting number of electrons. At a time, you are getting number of electrons. So the flow of large number of electrons results in large current. So see here you will get large current. At a time, you are going to get large current, means current is increasing rapidly due to bunch of electrons. The voltage at which this rapid increase of current takes place is called as breakdown voltage. This voltage VBD is called as breakdown voltage. So this we call it as breakdown voltage. The voltage at which current increases rapidly due to avalanche multiplication of electrons. Okay. So this is about reverse bias. So see here, the minority electrons in P region and holes in the N region wander over the junction and flow towards their majority carrier side, giving small reverse current called as reverse saturation current. So there is current due to minority charge carriers. Next, for large reverse bias, the free electrons from N region move towards P terminal of the battery, acquire sufficient energy to move with high velocities. So the electrons, minority charge carriers, will be getting sufficient energy and it collides with other crystal ion and it removes electrons. So rapid number of free electrons gives multiplication of electrons which rises current rapidly. So the voltage at which current current rises rapidly is called as breakdown voltage, represented by VBD. So this is about forward bias and reverse bias. These are the different biasing conditions in PN junction diode. Thank you.